Hey guys, welcome back to my channel Success Engineering Official. Today we are going to see the chilled water pipe design. How to design the chilled water pipe size, chilled water pipe sizing or chilled water pipe designing. So before I start this video, I would like to request you to please do subscribe my channel and don't forget to like and share my video. So let's start now. तो वीडियो स्टार्ट करने से पहले आपसे रिक्वेस्ट है कि हमारे वीडियो को लाइक करें, शेयर करें, कमेंट करें और हमारे चैनल को सब्सक्राइब करके बेल आइकन को दबा लें ताकि अगली आने वाली वीडियो का नोटिफिकेशन आपको मिल सके। तो चलिए वीडियो को स्टार्ट करते हैं। तो आप देख सकते हैं यहाँ पे एक लेआउट है। दिस इज राइजर डायग्राम, इसमें चिलर पंप एंड दिस इज द पाइपिंग नेटवर्क एंड दिस इज द HU. So we have to calculate the size of this pipe, so chilled water supply and chilled water return. You can see this is the pump. This is the chilled water return coming from this HU going to the pump section, and this pump will discharge and send to this chiller. Again this chiller, from the chiller this chilled water supply is going to each HU. So let us start now how to design this, how to size this pipe for supply and return. So I have one Excel sheet, I will tell you guys. Let me open this. You can see this is the chilled water pipe sizing or designing. This recommended velocity for riser piping. Actually this required parameter to design the chilled water pipe is flow rate in GPM. And then chilled water piping layout, and then third one is velocity in feet per second, and you have to calculate this friction loss, head loss, feet per 100 feet of pipe length. Then see the standard chart for manual calculation, and pipe sizer is required for shortcut calculation. And there are two methods actually for chilled water pipe designing. Velocity method, first one, and second one is velocity plus friction method. So we have to use for first method first, velocity method, and then we will see the second method. This is the required parameter actually for designing of chilled water pipe. Flow rate in GPM, and 1 GPM is equal to 3.78 liter, and for a standard chiller this chilled water supply temperature is 15 degree and chilled water return temperature is 60 degree. So delta T will be chilled water return minus chilled water supply, it will be 10 degree. And for other chiller other than extender, you can calculate flow rate from here, GPM into 24 divided by delta T. Okay. And this is the recommended velocity for roof piping, 15 fps maximum, and recommended is 10 fps. For riser piping, roof piping in the sense you can see the piping which is on the roof, running on the roof. So this is the roof piping. Okay. And this is the riser piping, the pipe which is going from the roof vertically to the shaft. So this is the riser piping. Okay, and this is the floor piping. So the velocity will be different for each pipe, floor pipe, roof pipe and riser pipe. So this is the recommended velocity, because to minimize the erosion, you can see this is the note 1. If you see this note 1, velocity of chilled water piping shall not be less than 1.5 fps. The maximum velocity in chilled water piping is 15 fps to minimize the erosion. Actually this is from the carrier handbook taken, this velocity, recommended velocity. I will show you this carrier handbook. If you go here, carrier handbook, let me open this. Piping design. So open this. So this is the pipe losses, pipe and fitting losses, you can see here this given in the carrier. Then water piping. So here is the recommended velocity. Let's see here. See the recommended velocity for riser 3 to 10, and this is the maximum velocity. You can see here, this is the table number 14, maximum water velocity to minimize the erosion, normal operation hours per year, and this is the water velocity in FPS, feet per second. 15 feet, you can see here, this is the 15 feet. Maximum velocity is 15 feet, and this is the Carrier handbook, Carrier air conditioning company. And this is the manual chart, as I told you here in this equate parameter, this standard chart for manual calculation. We will use this chart. Okay, this chart number 3, friction loss for closed piping, schedule 40 pipe. We calculate the pipe size from here. If you see this chart, this is the friction loss showing in this vertical line is showing friction loss feet of water per 100 feet, and this x-axis, this y-axis is showing this horizontal line is flowing GPM, and this line is showing velocity in feet per second, and this line is showing pipe size. You can see. So let us start now this calculating of the pipe size for using first method, velocity method. So from this drawing you can see this pipe size A2. Actually this roof pipe, for roof pipe we will calculate first. For roof piping, first one, chill water pipe design, chill water pipe sizing using velocity method. So is for roof piping. For roof piping, actually this A to A1, but we have to taken from A to B up to here. Okay, so A to B. So GPM will be, if you see here, this recommended velocity is 10 fps, and GPM, so required 2 parameter to calculate the pipe size and friction loss. If you see this table, flow rate and velocity is required to calculate the diameter and friction loss. So flow rate will be, if you see this one, this capacity of chiller is 6 ton. How to calculate I will tell you. And for 1440 GPM, this capacity is 6 ton. For example, if you see this flow rate calculation formula, if you will put this GPM here, then you will get this flow rate. Okay, actually 1 ton is equal to 2.4 GPM. If you see here, 1 ton, 1 tier is equal to 2.4 GPM. Okay, so the capacity of the chiller is given here 600 ton. So here is equal to 600. So GPM will be 600 into 2.4. Okay, 2.4. So it will be 600 into 2.4. So it will be directly, you have to use this calculator. 600, find here, 600 into 2.4. Okay, so 1440 GPM equal to 1440 GPM. Okay, and then velocity will be recommended velocity 10 fps. 10 fps. Okay, velocity is taken from here, this for the roof, so 10 fps. Friction loss, so using these two parameters GPM and velocity, you have to plot here in this chart. GPM will be 1440, so your GPM will be 1440 here. 1440 will be here. Draw a straight line 1440 and then 10 fps. Velocity is 10 fps, so here this is the 10 fps line. Draw one straight line parallel to this and just coincide this line. Where this coincide, you have to draw, and this line is nearby 8. You can see here, this is the 8-inch dia, and the velocity will be, if you draw here, so velocity will be, draw a straight line parallel to this line. You can see here this velocity will be 3.5 feet. So just note down here, clear this. So pipe size HF, here HF, head loss, HL1 is equal to, so here HF1 is equal to 3.5, HF1 is equal to 3.5 feet, 3.5 feet of water per 100 feet, feet of water, feet per 100 feet. Okay, and then pipe size, pipe dia will be 8 inch. Okay, then for roof piping, A to B done. Then next will be B to C. You can see riser B to C, then riser piping B to C. Roof piping is from A to B and the riser is start from B to C. Riser piping, next one. For riser piping, riser piping B to C, B to C. What will be the GPM? GPM will be this, if you see here 250 ton, this 250 ton AHU, the 250 ton means 600 GPM. 250 into 2.5, 625, so 600, we consider 600 GPM. So 1440, total GPM is 1440 minus, if you see this is the branch, so 600 GPM is gone to this AHU, remaining will be this in this riser. How much will be the remaining? So 1440 minus 600, 840 GPM. So here GPM will be 840 and velocity will be will be 7 fps. Okay, for riser velocity will be 7 fps. You can see here the riser is 7 to 10 fps, but recommended is 7, so 7 fps. Then using these two parameters you have to calculate the pipe size. What will be the head loss? Check to head loss, friction loss, or you can say friction loss HF2 is equal to how much? Then pipe size, pipe dia. You have to calculate the pipe dia. Okay, so using this chart 840 and 7 fps, you have to again check here 840. Again you have to plot 840. So this is the 800 and this is the 840. You plot, and this 7 fps, velocity is 7 fps. So this is the 3, 4, 5, 6 and 7. This is the 7. Okay, in between. Then this is the your pipe size, so it will be 8 inch. So you can see this is the 8 inch. Pipe size is 8 inch, and again this 1.5, so 1.8 feet friction loss. If you draw this vertical line here coinciding this, you can get here 1.5, so 1.6, 1.7 fps. Okay, so simply what you will do, put it here, friction loss is 1.8 fps, 1.8 feet per 100 feet. Okay, the pipe size will be 8 inch. Similarly you have to calculate the riser piping, and now next is C. Riser piping C to D. You see here, then C to D, and this is the floor piping. So C to D, riser piping again C to D. Simply I am copying this and put it here. Riser piping C to D. C to D. What will be the GPM? If you see the total is for B2C 840, then again 480 will goes to this AHU. So 840 minus 480 GPM, because this 200 ton AHU, so 480 GPM for this. So 360 will be this. So you can see here this for this AHU 360 GPM. So GPM will be 360 here. 360 GPM. Okay, and the velocity is 7 fps. So using these two parameters you have to calculate this pipe size and head loss. So 360 and 7 fps you have to plot here. If you plot here 360 is this one and 7 fps. Pipe size will be 5 inch. You have to, this is the pipe size 5 inch and head loss is 2.8. Head loss is 2.8 and pipe size is 5 inch. So if standard pipe is 5 inch not available, you have to go for higher size. So it will be 6 inch. Okay. And then roof piping D. Next is floor piping. Floor piping D to E. What will be the GPM? GPM will be 360 and velocity will be, you can see here for the floor piping velocity will be 5 to 7 fps, so recommended is 5 fps. Okay. And using these two parameters again you have to calculate the pipe size and friction loss, head loss. So go to this chart number 3. This is taken from Carrier. You can see here this is taken from the Carrier handbook. So 360 GPM, here is the 360, where 360 is the here and velocity is 5 fps. So this is the 5 fps, so your pipe size will be 5 inch and friction loss will be 1.8 again. Just copy this, paste it here. Friction loss HF4, here will be HF4. HF4 is 1.8 and pipe size is 5 inch, so again consider again it is 6 inch. Okay, and here is HF to HF3. Okay, so I hope you have you learn how to calculate this pipe size and how to design the chilled water pipe sizing. Similarly, you have to calculate for the return pipe also. This is in the return pipe. F to G is the floor piping, and G to H, H to I, then H to I is the riser piping, then J to I is the floor piping, roof piping, and K to L also you have to calculate in the roof. The velocity for roof piping is 10 fps you have to take, and you have to calculate the similarly for this return piping also. So I hope you guys learn from this video the chilled water pipe designing. So अगर आपको हमारा वीडियो अच्छा लगा होगा तो प्लीज़ हमारे वीडियो को लाइक करें, शेयर करें, कमेंट करें और हमारे चैनल को सब्सक्राइब करके बेल आइकन को दबा लें ताकि अगले आने वाले वीडियो का नोटिफिकेशन आपको मिल सके। तो नेक्स्ट ट्यूटोरियल में हम देखेंगे चिल्ड वाटर पाइप डिजाइन यूजिंग वेलोसिटी एंड फ्रिक्शन मेथड विथ मैनुअल कैलकुलेशन। देन हम नेक्स्ट देखेंगे चिल्ड वाटर पाइप डिजाइन यूजिंग सॉफ्टवेयर मेथड। You can see this is the pipe sizer software. This is from Macway actually. So we have to use we are using in the actual practice these tools, pipe sizer tools, in the actual practice to design the chilled water pipe. So we will tell you in the next tutorial how to design using velocity and friction method, then how to design using pipe sizer. You can see here as pipe sizer for software calculation. So in the actual practice we are using this software, but just to learn this concept I am telling you this manual calculation with the standard chart. So the pipe sizing with second velocity and plus friction method, we will use this software pipe sizer. Okay, so thank you for watching my video. Thank you. Bye bye.